Jadi cuma usah lo ya.
Yeah, okay.
Yeah.
Good afternoon, my senior colleagues and junior colleagues and all participants. Welcome to paper presentation section 3. In this section, 5 researchers will present their papers. The presentation is allowed 10 minutes for each speaker. Therefore, may I request all the speakers to present within the allotted time as possible. And Q&A section will be collectively done after all presentations. Participants who wish to ask the question, please write the question in the chat box, including the name of the speaker, name or number of the speaker to respond the question. Okay, so let me call upon the first speaker, Dr. Tatan Nue, to present the paper regarding the ratio of serum omega-6 and omega-3 in obese adult. Nue, please.
Good afternoon to all honorable person, Chairperson, Professor, seniors and junior colleagues attending to this session. I'm Dr. Tatan Nue from Department of Biochemistry, University of Medicine, Yangon. Today, I'm here to present my article, Serum omega-6 to omega-3 fatty acid ratio and high sensitivity C-reactive protein, hsCRP levels in obese adult. To briefly introduce, obesity has become one of the significant public health problems in both developed and developing countries. According to the World Health Organization 2018 report, about 30% of the world population, 11% of men and 40% of women were obese in 2016. Obesity is the consequences of the excessive accumulations of fats in adipose tissue and the states of low-grade inflammation. And adipose tissue is an important endocrine organ that secretes inflammatory cytokines such as interleukin-6, TNF-alpha, interleukin-1. These inflammatory cytokine expressions and release from adipose tissue is increased in case of obesity. In obesity, dietary fats and quality of fat may be considered as one of the risk factors for metabolic diseases. The 2 essential fatty acids, such as alpha-linolenic acids and linoleic acid, that cannot be synthesized in our body and that must be supplied in the diets. ALA is the precursor of omega-3 puffer and LA is the precursor of omega-6 puffer. In the human diet, must contain the right proportions of omega-6 and omega-3 puffer, such as linoleic and alpha-linolenic acid, because they are the precursors of all other puffers and its metabolites. In our daily life, there has been reduction in saturated fatty acid, but enormously use of omega-6 polyunsaturated fatty acid containing Y. This leads to the states of omega-6 to omega-3 puffer ratio has increased from 4:1 to the current diet estimate of 20:1 or higher. The imbalance between omega-6 and omega-3 puffer stated may play a role in the pathophysiology of nutritional related health disease in humans. ALA has many health-promoting, disease-preventing or medicinal properties. It also has the cardioprotective effect, anti-inflammatory effects, and anti-cancer effect. ALA, omega-3 puffer, and its metabolite had anti-inflammatory action because it can inhibit the expression of gene encoding the inflammatory protein. In contrast, linoleic acid, LA, omega-6 puffer, and its metabolites such as arachidonic acid plays a significant role in contributions of membrane phospholipids of many inflammatory cells. And then it also the precursors of various pro-inflammatory cytokines, cytoeicosanoids, involved in inflammation. Elevated production of pro-inflammatory eicosanoid could increase the levels of biomarkers of low-grade systemic inflammation, such as C-reactive protein by the liver. And so, in the present study, the comparisons of serum hsCRP, linoleic acid, alpha-linolenic acid, LA/ALA ratio between obese and non-obese adult was investigated. And then analyze the association between serum hsCRP levels and LA/ALA ratio in obese and non-obese adult. Methodology. It was a cross-sectional comparative study conducted from the January 2018 to October 2019. The study population for the study is apparently healthy obese and non-obese adult, including both male and female of age 35 to 65 years living in Oglapa Township. Total 60 subjects were separated into the 2 groups according to the BMI more than 25 kilogram per meter square or weight circumference more than 90 centimeter for male and more than 80 centimeter for female for the obese group according to the WPRO criteria 2000. BMI 18.5 to 22.9 kilogram per meter square or weight circumference 78 to 90 centimeter for male and 64 to 80 centimeter for female for non-obese group. Subjects who were taking omega-3 puffer and omega-6 puffer supplementation, lipid-lowering agent, chronic use of NSAID were excluded from the study. Subjects who were voluntarily participated were selected according to the inclusions and exclusion criteria, and then they were instructed to do overnight fasting, and in the next morning, fasting venous blood about 5 ml was collected. Serum LAs and ALA were determined by using the high-performance liquid chromatography, HPLC, in the Biochemistry Laboratory, Faculty of Medicine, Chiang Mai Medical University, Chiang Mai, Thailand. Serum HSCRP level was determined by using the solid phase ELISA in Common Research Lab, University of Medicine, Yangon. Data entry analysis were done by the starter ICP 14.0 and summary statistics for continuous behavior were presented as mean plus or minus ST. Correlation between behavior were evaluated by using the Pearson correlation coefficient test. Level of significance was P less than 0.05. Results and discussion. This table shows the comparisons of serum HSCRP, linoleic acid level, alpha-linolenic acid level, and serum LE by ALE ratio between non-obese and obese adult. Values are expressed as mean plus ST for the subject in each group and statistically significant setup P less than 0.05. This table shows serum HSCRP level was relatively higher, significantly higher in obese group than the non-obese group. Serum LE level was relatively higher in obese group than the non-obese group, but the difference is not statistically significant. ALE level between obese and non-obese adults show no statistically significance. LA by ALE ratio was relatively increased in obese group than the non-obese group, but the difference is not statistically significant. In Myanmar, the prevalence of overweight and obesity in both sexes were 90% and 7% respectively in the age group of 45 to 54 years of age, according to the WHO stepwise survey in 2009. In case of obesity, dietary fats and quality of fat plays a major role. Dietary polyunsaturated fatty acid influence the process of inflammation through the varieties of mechanisms. In the present study, fasting HSCRP level was significantly higher in obese group than the non-obese group. It could be suggested that there is a low-grade systemic inflammation in obese group. Human adipose tissue express and release a pro-inflammatory cytokine interleukin 6. This interleukin 6 induces the acute phase protein protection in the liver, such as C-reactive protein. The mean serum LE level of obese group was slightly higher than those of the non-obese adult, but the statistically significant difference wasn't found. The mean serum ALE level of obese and non-obese adult was show no statistically significance. Serum LE by ALE ratio in obese subject was slightly higher than those of the non-obese adult, but the statistically significant difference wasn't found between the group. Dietary intake may reflect the serum concentrations and also affect the body response to inflammations and obesity. LA is mostly obtained in daily cooking wine, but ALA source for the body is from the flaxseed, chia seeds, and walnut. Serum LA level was higher in obese group. It could be that LA and its metabolite enhance the adipocyte differentiations and proliferation. Many experimental studies have suggested that omega-6 and omega-3 fatty acid elicits the divergent effects on adipogenesis, lipid homeostasis, and most importantly, systemic inflammation. This figure shows the correlation between serum LA by ALE ratio and serum HSCRP levels in obese study population. There was a positive correlation between serum LA by ALE ratio and serum HSCRP levels in obese group. However, the correlation is not statistically significant. These findings also suggest that high omega-6 by omega-3 ratio might provoke for the severities of inflammation expressed by serum HSCRP concentration. The mean serum LA by ALE ratio is 7.10 plus or minus 3.68 in study population, and it was suggested that there was a relatively high intake of omega-6 fatty acid in the diet. The widely use of high omega-6 content wine in people lead to the high concentrations of LA in the serums and promote the risk of non-communicable diseases in humans. The similar study in India reported that relatively increased intakes of high omega-6 by omega-3 buffer ratio 38 to 50 was observed in urban India population, then in rural India population was 5 to 6.1. This table shows association between serum LA by ALE ratio and abdominal obesity in study population. There was a significant association between abdominal obesity and serum LA by ALE ratio. Among the participants with abdominal obesity, 67.9% had high serum LA by ALE ratio. It could be suggested that elevated LA by ALE ratio is associated with body fat, especially the visceral adipose tissue. The dietary fat quality affect the abdominal fat content. Increased intakes of LA than ALA lead to compete the enzyme delta 6 and delta 5 desaturate for the desaturations and formations of its metabolite. High LA level interferes the desaturations and elongations of ALA to DHA, EPA, and its metabolite. Today, highly dietary LA intake from vegetable oil that lead to increased synthesis of AA from the LA. Eicosanoid metabolic products from AA are specifically prostaglandin, thromboxane, leukotrienes, and lipalsane. The development and perpetuations of obesity and adipogenesis is stimulated by the AA and it-derived eicosanoids. This figure shows the metabolism of omega-6 and omega-3 polyunsaturated fatty acid in our body. Moreover, the balanced omega-6 to omega-3 ratio is important for health and prevention and management of obesity. According to the study of the CHROMA 2014, an imbalanced omega-6 by omega-3 ratio in the favor of omega-6 puba is highly prothrombotic and pro-inflammatory, which contribute to the prevalence of atherosclerosis, obesity, and diabetes. In conclusion, the present study reported a significant association between serum LA by ELA ratios and abdominal obesity in the whole study population. And then abdominal obesity is one of the risk factors for metabolic syndrome. Dietary PUFA intake must be considered properly in the treatment and prevention of non-communicable diseases. Conclusion. In the present study, relatively higher serum LA1-ELE ratio in obese group and weak positive correlation between LA1-ELE ratio and serum hsCRP levels in obese group. These results reflected that serum omega-6 fatty acid was shown to promote low-grade inflammation. The essential fatty acid ratios of LA to ELE is positively associated with abdominal obesity in the study population, and so it can be concluded that elevated LA1-ELE ratio is associated with body fat, especially the visceral adipose tissue. These are my references. Thanks for your attention and any questions, comments, and advice.
Thank you, Dr. Tatanre, for your informative presentation. So can I go for the next speaker? The next speaker is Dr. William Han, who will present on serum LGAT-CETP ratio in hyperlipidemia patients. So Dr. William Han, can you share your slides and continue?
Good evening to my honorable chairperson, senior and junior colleges. I am Dr. William from Department of Biochemistry, University of Medicine, Yangon. Today, I would like to present my article, Serum lecithin cholesterol enzyme transferase to cholesterol ester transport protein ratio in different categories of hyperlipidemia. Regarding introduction, hyperlipidemia is one of the major risk factors causing cardiovascular disease. It is also a major cause of atherosclerosis and atherosclerosis-related conditions like coronary heart disease, ischemic cerebrovascular disease, peripheral vascular disease, and pancreatitis. The increasing prevalence of hyperlipidemia has become worldwide public health problem. Hyperlipidemia is an increase in one or more of the plasma lipid, including triglyceride, cholesterol, cholesterol ester, and phospholipid, and or plasma lipoprotein, including VLDL, LDL, and reduced HDL level. Any impairment in synthesis, transport, and metabolism of lipoprotein can lead to hyperlipidemia. Lecithin cholesterol enzyme transferase LCAT and cholesterol ester transport protein CETP play a pivotal role in the lipoprotein metabolism and lipid transport throughout the body. Both LCAT and CETP are key factors in the reverse cholesterol transport process, which is important for the removal of excess cellular cholesterol from peripheral tissue and its delivery to the liver for the excretion into the bile. Several studies reported that plasma CETP level was increased in different categories of hyperlipidemia. Evers et al. 1981 also reported that plasma LCA level of hyperlipidemic subject was higher than that of normal lipidemic subject. However, the relation of these two proteins in hyperlipidemia was not discovered yet. Therefore, this study was aimed to analyze the serum concentration of LCA and CETP in different categories of hyperlipidemia and to find out the variation in LCA to CETP ratio in different categories of hyperlipidemia and find out the correlation of this ratio with lipid parameters in different categories of hyperlipidemia. Regarding materials and method, this is the laboratory-based comparative study. Both male and female aged 25 to 60 years from North Oklahoma Township participated in this study. Subjects who were taking lipid-lowering drugs, oral contraceptive, beta-blockers, steroids, and subjects with no history of diabetes mellitus, liver disease, and kidney disease were excluded from the study. Subjects who voluntarily participated were selected according to the inclusion and exclusion criteria. Then subjects were instructed to do overnight fasting, and in the next morning, fasting venous blood about 6 ml was collected. Serum triglyceride, total cholesterol, and HDL cholesterol levels were determined by using enzymatic calorimetry method. Serum LDL cholesterol level was determined by using the Frederick formula. And then the subjects were characterized into 4 groups according to the lipid profile result, that is hypercholesterolemia, hypertriglyceridemia, combined hyperlipidemia, and normal lipidemia according to the National Cholesterol Education Program ATP3 2002. According to the lipid profile result, total 197 subjects were included in this study. Then the serum, CETP, and LCA concentration of the subjects were determined by the ELISA method. Statistical analysis was performed with computer-based SPSS software. Continuous data were summarized by me and SD. The mean values of variables among different groups were compared by using one-way ANOVA test, followed by Bonferroni post-hoc test. Correlation between the variables were evaluated by using PSN correlation coefficient test. Levels of significance were set at P less than 0.05. Result and discussion. This table shows the demographic characteristic and lipid profile status of the study population. According to one-way ANOVA test, the mean serum CETP concentration of the 4 study group was significantly different with P 0.000. And when compared with normal lipidemic subject and CETP concentration of the hypertriglyceridemic subject, hypercholesterolemic subject, and combined hyperlipidemic subject were significantly higher with these P values. These findings were well comparable with the previous study and the study done by Winchell 2015. In high serum CETP concentration in hyperlipidemic subject was postulated to be due to the induction of CETP gene by cholesterol. Significant increase in plasma concentration of CETP double with increase in the concentration of LDL cholesterol in response to cholesterol feeding in normal subject. In animals, an increase in dietary cholesterol leads to an increase in CETP messenger RNA in both liver and adipose tissue in association with increased plasma. Induction of CETP gene expression in response to dietary cholesterol was probably due to the presence of S-strain natural planting sequence of human CETP gene, which being responsible for the steroid-mediated induction of gene expression. However, another study reported that the rise in CETP level is not the effect of rise in cholesterol level, but it might be the cause of increased cholesterol level. This may be due to the basic function of CETP. The CETP transfer cholesterol ester from HDL to chylomicron and VLDL and their remnants, and also to LDL. High CETP activity due to increased CETP concentration result in increased rate of transfer of cholesterol ester from HDL to acceptor particle, causing a decrease in cholesterol concentration of HDL and increase in cholesterol ester concentration in acceptor particle. These cholesterol ester enriched particles return cholesterol to the liver via remnant receptor as well as LDL receptor, thereby increasing reverse cholesterol transport to the liver. As a result of increased uptake of cholesterol by the liver, the LDL receptor in the liver may be downregulated in response to increased intracellular cholesterol level. This may contribute to the reduced clearance of cholesterol ester-rich LDL, which then accumulate in the plasma. As for ALCA, the serum ALCA concentration among the 4 study group were also significantly different with P equal to 0.000. When compared with normal lipidemic subject, ALCA concentration of hypercholesterolemic subject, combined hyperlipidemic subject was significantly higher, but there was no significant difference between normal lipidemic and hypertriglyceridemic subject. Evers and colleagues also reported that the mean plasma ALCA level of hypercholesterolemic subject was significantly higher than that of normal lipidemic subject. Also, the mean plasma ALCA levels of the subject with dyspeptide lipoproteinemia and hypertriglyceridemic subject were significantly higher than that of normal lipidemic subject. Therefore, the finding of the present study had a similar trend with the previous study, except that the mean serum ALCA concentration of hypertriglyceridemic subject was not significantly higher than that of normal lipidemic subject. This discrepancy could be due to the difference in genetic or ethnic backgrounds or dietary habits of the participant. From the finding of the present study, it could be postulated that serum ALCA concentration is largely concerned with hypercholesterolemia and combined hyperlipidemia. Based on functional ALCA on HDL metabolism, ALCA present on HDL particle esterifying the cholesterol taken up by HDL from the peripheral cell and drive the maturation of small dense latent HDL discs to larger spherical-shaped HDL2 and thereby facilitating the reverse cholesterol transport. In the presence of CETP, cholesterol ester formed by ALCA action is transferred from HDL to ApoB containing lipoprotein such as chylomicron, VLDL, and their remnants, and leads to increased LDL cholesterol. Moreover, ALCA is also able to bind to LDL particles and produce cholesterol ester on LDL particles, thereby causing increased LDL cholesterol level. However, ALCA gene is relatively insensitive to dietary lipids and cholesterol. It can be assumed that plasma lipids do not have a significant impact on regulation of ALCA gene expression. Therefore, it is uncertain to determine that hypercholesterolemia is either the effect or cause of increased ALCA concentration. As for ALCA to CETP ratio, mean ALCA to CETP ratio of the 4 study groups were significantly different with P 0.003 when compared with normal lipidemic subject. Only the ALCA to CETP ratio of the hypercholesterolemic subject was significantly higher with P 0.003. One, the correlation and Pearson correlation between the ALCA to CETB ratio and serum lipid parameters in the 4 study groups were analyzed, there was only a significant negative correlation between the ALCA to CETB ratio and triglyceride and hypertriglyceridemia subject. This negative correlation was parallel with decreased ALCA to CETB ratio in hypertriglyceridemia subject. Regarding conclusion from this study, it can be concluded that both ALCA and CETB play an important role in lipid metabolism, and high serum CETB and ALCA concentration have a great impact in different categories of hyperlipidemia. Although it is uncertain to decide whether it is the etiology or consequence, it can be assumed that both CETB and ALCA function balancedly for transport and removal of acyl lipid in hyperlipidemia. ALCA and CETB ratio were nearly 2 in hypercholesterolemia and combined hyperlipidemia, and it indicated that high serum CETB concentration could be greatly concerned with high cholesterol level. To confirm that whether high ALCA concentration is the cause or consequence of hypercholesterolemia, future studies should be done in vitro study. These are my references. Thank you very much for your kind attention.
Oh, sorry. So thank you, Dr. Willingham, for your informative presentation. So from now on, I will hand over the session to Professor Nunui for the rest of the presentations.
Yes, thank you, Dr. Dumont. So now I'd like to invite the speaker 3, who is Dr. Mao Mong Cho from, he's assistant lecturer from University of Medicine, Tongji. So he would like to present on effect of hydroxychloroquine on insulin sensitivity in established rheumatoid arthritis. Please.
Good evening, everyone. I am Dr. Mamang Chao from University of Medicine, Tongji. Today, I will talk about effect of hydroxychloroquine on insulin sensitivity in established rheumatoid arthritis. Let's start with introduction. As we know, rheumatoid arthritis is a chronic systemic inflammatory disease that, without treatment, lead to permanent joint damage and destruction. In response to epidemiology, every year, 0.5 to 1% of adult population worldwide is affected by RA. The incidence rate is as shown between 5 and 50 per 100,000 people. The risk of RA in a female to male ratio is 3:1. RA is one of the most common rheumatological diseases. In Myanmar, RA was 25.69% of outpatients attending the rheumatology OPD clinic. RA patients were at increased risk of insulin resistance through elevated level of tumor necrosis factor alpha and interleukin-6, consequently diabetes mellitus. Abraham and Zinn found that the relative risk for diabetes was increased approximately 20% in RA patients with mean disease duration of 16.8 years. According to the study done by Dr. Kinyemi, among 222 RA patients on low-dose steroid therapy, 90% developed steroid-induced diabetes mellitus within 4-month follow-up period, with 81% didn't. Hydroxychloroquine is a conventional synthetic GMAT. There were many studies in which the effect of hydroxychloroquine on insulin sensitivity was investigated by using homeostatic model assessment of insulin resistant HOMA-IR as an indicator. The study of Solmo and Pan stated that the use of hydroxychloroquine might improve glycemic control in RA patients. Therefore, the present study aimed to investigate the effect of hydroxychloroquine on insulin sensitivity in established RA patients. The objective of the present study: number 1, to determine the effect of hydroxychloroquine on insulin sensitivity in patients with established RA. Number 2, to compare insulin sensitivity between study group, hydroxychloroquine group, and control group, non-hydroxychloroquine group by using HOMA-IR. Now move on method and procedure. The present study was a randomized controlled experimental study done at Rheumatology OPD Clinic of 500 bedded Specialty Hospital, Yangon. Inclusion criteria of the present study were age between 80 and 60 years, both sex, low to moderate disease activity, patient with disease duration more than 6 months, and patient who could get next morning. Exclusion criteria of the present study were patient with disease duration less than 6 months, patient who had history of hypersensitivity to ACE2, coexisting retinopathy, GCPD deficiency, abnormal liver function test, and abnormal renal function test. Patients who were taking treatment that affect blood glucose level. Here is flowchart of the study procedure. The recruitment of established eye patient diagnosed by rheumatologist was done, and the selected patient needed to take only one DMAT, methotrexate or leflunomide. Both oral and written informed consent were taken. To identify disease activity, 2 ml of blood was taken for ESR estimation. Disease activity score in 28 joints using ESR was calculated. Based on calculation, test 28 ESR score more than is equal to 2.6 to less than is equal to 5.1. Total 56 patients were recruited. Test 28 ESR score less than 2.6 and more than 5.1. Total 26 patients were excluded from the study. By using computerized randomization method, the patients were randomly allocated into study group and control group. The patient in the study group had to take hydroxychloroquine 200 mg in addition to standard treatment. The patient in the control group had to take only standard treatment. Here, standard treatment means taking methotrexate or leflunomide plus 1 NSAID plus prednisolone dose less than 10 mg per day. Collection of patient data were done according to pro forma. Next morning, full measure of blood sample was collected for measurement of fasting plasma glucose and fasting serum insulin. Within 4 hours of sample collection, measurement of fasting plasma glucose was done by using spectrophotometer. During the study period, 3 patients from the study group and 2 patients from the control group were withdrawn because of their loss of follow-up. Moreover, 1 patient from the control group was also withdrawn because her disease activity became high. So, 25 patients in each group completed the study. After 12-week intervention, 4 ml of blood sample was collected for measurement of fasting plasma glucose and fasting serum insulin. After 12 weeks of treatment, measurement of fasting plasma glucose was done within 4 hours of sample collection. Then, measurement of fasting serum insulin for both baseline and after 12 weeks of treatment was done by using ELISA. Finally, HOMA ion calculation was done for both baseline and after 12 weeks of treatment. This bout began the objective of the study. Comparison of fasting plasma glucose, fasting serum insulin, and HOMA ion between study group and control group was done. This is HOMA ion index formula. In the current study, the normal HOMA ion cutoff point used was 1. Ethical consideration. The present study had been approved by the Ethical Review Committee of University of Medicine, Yangon. There was no conflict of interest in the present study. Result. Age distribution of study group and control group. The mean age value between study group and control group show no significant difference. Sex distribution of study population. Here we see IA is more prevalent in female population. Baseline characteristic of established IA patient. The baseline parameter between study group and control group show no significant different data. This is continuation of the previous slide. The remaining baseline parameters show no significant difference between study group and control group. In the hydroxychloroquine group, comparison of fasting plasma glucose, fasting serum insulin, and HOMA ion as shown below. Fasting plasma glucose was significantly decreased with p-value less than 0.001 before and after treatment. The remaining parameters such as fasting serum insulin and HOMA ion show no significant difference. Though fasting serum insulin was not statistically significant, it appeared to increase after treatment. In the control group, the comparison of fasting plasma glucose, fasting serum insulin, and HOMA ion before and after treatment show no significant different data. After 12-week treatment intervention, comparison of fasting plasma glucose, fasting serum insulin, and HOMA ion between study group and control group show no significant different data. Discussion. In the study group of the present study, although fasting serum insulin were statistically increased after 12-week treatment with hydroxychloroquine, the mean fasting serum insulin value were 7.2 before treatment and 7.9 after treatment. The above finding of hydroxychloroquine increasing insulin action due to decreased hepatic insulin metabolism is comparable to the study done by IMMI, in which HC2 had lower insulin clearance, resulting in increased insulin level and subsequently lower glucose level. This finding of blood glucose lowering action is comparable to the glucose lowering action in the present study. In the study group of the present study, mean fasting plasma glucose was significantly decreased after 12-week treatment with hydroxychloroquine, though the reduction was not statistically significant when compared to the control group. Therefore, the present study suggested that hydroxychloroquine might have a favorable effect on blood glucose. This finding of blood glucose lowering action is similar to the study done by Pan et al. In 2010, Pan et al. Performed a discrete cross-sectional analysis in 177 non-diabetic women with RA, in which mean fasting glucose level were 88.4 for non-HC2 user and 85.1 for HC2 user. Hormone value change in the present study is not statistically significant between the study group and control group after 12 weeks of treatment. This finding of no significant association between hydroxychloroquine and hormone is comparable to the study done by Solomon et al. In 2014, Solomon et al. Performed a 16-week double-blind crossover study in 23 eye subjects, in which hormone was decreased during hydroxychloroquine period and the hormone was also decreased during the placebo period. Summary. The addition of hydroxychloroquine 200 mg to the combination chemotherapy showed reduction of fasting plasma glucose after 12 weeks of treatment, though the reduction was not statistically significant when compared to the control group. Fasting serum insulin and hormone value were not changed significantly between study group and control group after 12 weeks of treatment. Conclusion. From the present study, it can be concluded that the addition of hydroxychloroquine failed to show significant effect in increasing insulin sensitivity in established RA patients. There was also no significant difference in insulin sensitivity between study group and control group by using HOMA-IR. Here are the reference of the present study. In my mind, I'm glad to be a part of free paper session in 67th Market Medical Conference. Thank you for your kind attention.
So thank you very much, Dr. Momongcho, for your very comprehensive presentation. So let's move to another speaker, it's Nying Kei Kai. She presented antimicrobial utilization pattern and sensitivity profile of patient admitted at Medical Ward, New Yangon General Hospital. Nying Kei Kai, please.
Good afternoon, Professor and colleague. I would like to present for 67 Medical Conference with the title of Antimicrobial Utilization Pattern and Sensitivity Profile of Patient Admitted at Medical Ward, New Yangon General Hospital. For introduction, drug utilization research means the marketing, distribution, prescription, and use of drug in a society with special impact on the medical, social, and economic consequence. Drug utilization research is important, especially for antimicrobial. The reason is that antimicrobial are widely used in healthcare. Utilization of antimicrobial is also varies even in the same country. Utilization pattern tend to change according to development and mutation of bacteria and virus species. The ATC-TTD system is used as a tool for presenting drug utilization statistics for improving drug use. It allows standardization of drug group and represent a stable drug utilization metric to enable comparison of drug use between country, regions, and other healthcare systems. ATC classification system has 5 levels. The first level is anatomical main group. The second level is pharmacological subgroup. The third level is chemical subgroup. The fourth level is therapeutic subgroup. And the fifth level is chemical system. Defined daily dose (DDD) is a technical unit of measurement. It is the assumed average maintenance dose per day for a drug used for its main indication in attack. It estimates the most commonly prescribed antimicrobial agent, which are WHO standardized dose. Drug utilization 90%, DU 90% is a simple method for assessing the quality of drug prescribing. It's focused on drugs that 90% of the prescribed volume, the remaining 10% for drugs used for the rare condition to patients with drug intolerance, adverse event, complex comorbidity, and all therapy. The DU97 are very important for the strict monitoring of resistability to prevent the antibacterial drug from becoming resistant. The objectives are to determine the utilization pattern of antimicrobial agent by using the ATC code and DDD per 1000 inhibited per day and DDD per 100 per day. To describe the common microorganisms isolated in culture and their antibiotic sensitivity profile. For material method, my study design was a hospital-based discrete study. It was carried out for treatment at the medical ward of New Yangon General Hospital. Study population were all the admitted patients who were prescribed antimicrobial therapy. The defined daily dose DDD or cetrazole in this study was calculated by the following formula. Number of DDD equal to number of items used into amount of drop per item by WHO recommended DDD or drugs. After calculation, total concentration in DDD or cetrazole is 131.9 DDD. DDD per 1000 inhibited per day or cetrazole in this study was calculated by the following formula. DDD per 1000 inhibited per day equal to total number of doses unit prescribed into stretch of each doses unit into 1000 by DDD into duration of study into total sample size. After calculation, utilization of cetrazole is 3.72 DDD per 1000 inhibited per day. Also, DDD per 100 per day was calculated by the following formula. DDD per 100 per day equal to number of unit administered into 100 by DDD into number of bed into bed occupancy index into number of day in study period. Bed occupancy rate equal to total inpatient day for the given period into 100 by available bed into number of days spent in study period. After calculation, utilization of cetrazole is 4.8 DDD per 100 per day. For the flowchart procedure, among the patient admitted to medical ward or New Yangon General Hospital and the microbial prescribed group are selected. After taking consent, data collection from inpatient check and data collection from laboratory report. After that, drug utilization with the ATC DDD classification system was calculated and data were analyzed. And then describe the antimicrobial culture and sensitivity profile and data were summarized. This table shows the proportion of antimicrobial prescription amongst the 379 total number of admitted patients. 385 patients were prescribed antimicrobial. The percentage was 56.7%. Among them, 69% were given a combination therapy and 31% given single therapy. This table shows the drug utilization of antimicrobial agents and results of DDD per 1000 inhibited per day and DDD per 100 per day. This table is the continuation of the drug utilization of antimicrobial agent. For my result, total utilization of antimicrobial drug is 37.9 DDD per 1000 inhibited per day. This means that 3.5% of the study population on average might receive standard dose of antimicrobial every day and 48.3 DDD per 100 per day. This means that 48.3% of inpatients receive the antimicrobial every day. For the discussion, informant study on Leleso in medical ward of Macquarie Regional General Hospital Antimicrobial concentration was 55.55 DDT per 1,000 inhibited per day. In treatment study or handling out in number 2 DSG8, antibiotic concentration was 51.31 DDT per 1,000 inhibited per day. Although study duration was not much different, in larger amount of antimicrobial was prescribed in study or LLSO and handing out. The difference between the present study and the study could be affected by the characteristic of patient coverage, seasonal different and antimicrobial availability. The uses of, for the discussion, the uses of antimicrobial drug in Italy was 60.1 DDT per 1,000 inhibited per day during 6 years study period. The study done in Oroda National Reference and Hazard Sonas Referral Hospital from January 2014 to December 2018, where utilization was 87.8 DDT per 100 per day and 35.4 DDT per 100 per day, respectively. This difference may be due to the differences in the duration of study, severity of patient condition, prevalence of diseases, and resistance pattern, and the availability of drug. In the present study, of the 30 antimicrobial agents, 20 drugs were involved in DU90 segment as shown in the table in the next slide. This table shows the drug utilization 90%, amoxicillin and beta-lactam inhibitor was most commonly prescribed agent. This table also shows that aware classification of antimicrobial, simple AMI, ASA group, simple W and AMI, wash and ASA group, symbol of AMI reserve group. For the aware classification group, antibiotic into the following category: ASA group, wash group, as reserve group. Assess me, which designed the first one antibiotic, and those must be available for all time in health system. Wash group mean antibiotic at the higher risk of resistance and should be prescribed only when first line does not wash, and reserve me for the last results. This part show the antibiotics of ASA, wash, and reserve group. According to WHO, Essential Medicine List, ASA group of antibiotic, this antibiotics such as amoxicillin, beta-lactam inhibitor, ampicillin, clindamycin, penicillin V, benzodiazepine, penicillin, gentamicin were most commonly used in the present study. Azithromycin, ceftriaxone, ciforazole, and beta-lactam inhibitor, cefotaxime, cefixime, cefixime, which were used in the present study, were included in WHO wash and ASA group. Currently, linezolid and cefepime are drugs listed in this study, which were included among the WHO Essential Medicine reserve list. Therefore, it was assumed that the antibiotics used at New Yangon General Hospital were consistent with WHO aware classification of antibiotics. This table shows the isolated microorganisms and their culture site. From the table, a gram-negative bacilli were predominant in sputum culture. Is seen that they are predominant cause of respiratory infection. Regarding the sensitivity pattern of Staph aureus, it was highly sensitive to linezolid, vancomycin, ciprofloxacin. Concerning resistant pattern of Staph aureus, it was resistant to ofloxacin, cephalexin. Regarding the antimicrobial resistant pattern of Pseudomonas species, it was resistant to cetirizine, cefurozine, cefotaxime, cefixime, ciprofloxacin, and vancomycin. Ongoing surveillance of antimicrobial susceptibility pattern had in preparation and regular review of local guidelines for the empirical selection of first-line antimicrobial agent. For the conclusion, therefore, the findings from the present study provide information for the implementation of hospital antibiotic guidelines in the treatment of viral infection. It's also useful in the decision of drug procurement and estimation of drug budget. The recommendation, the antimicrobial utilization pattern and sensitivity profile of microorganism is needed to be carried out periodically at different ward of hospital where culture and sensitivity is available. And then the antimicrobial utilization pattern in different hospitals would be done according to WHO aware classification to evaluate whether rational prescription drug is followed or not. For the ethical consideration, this research procedure was done after getting permission. For the conflict of interest, the author have no other conflicts of interest. Thank you for the kind attention.
Thank you very much, Dr. Nying Tee Khai, for your very informative presentation. So now the last speaker, Dr. Nushriwa, she will present the vancomycin, the ratio of plasma trough concentration to minimum inhibitory concentration and microbiological outcome in hemodialysis patient with end-stage renal disease. Please, Dr. Nushriwa, please. Yes. Mute. တမီ mute ဖြစ်နေတယ် unmute လုပ်လိုက်
Good afternoon, honorable chairpersons, respected professors, and dear colleagues. Today, I'm going to present about vancomycin, ratio of plasma trough concentration to minimum inhibitory concentration and microbiological outcome in hemodialysis patients with end-stage renal disease. I am Dr. Nushriwa, assistant lecturer from Pharmacology Department of University of Medicine 1. For introduction, hemodialysis is one of the treatment options for end-stage renal disease, and it is recommended to achieve improved quality of patients' life. Infections has been the second leading cause of death in patients undergoing chronic hemodialysis. Presence of central venous catheter and arteriovenous graft causes patients more prone to infections. Intravenous catheter and arteriovenous graft-related infections are responsible for 30% of the causes of hospitalization due to infection in hemodialysis patients. There are many bacteria causing bacteremia in hemodialysis patients. Among them, gram-positive bacteria are most common causative organisms, accounting for half to three-quarters of the causes. Staphylococcus aureus, including methicillin-resistant Staphylococcus aureus, account for 50.9% of hemodialysis vascular access-related bacteremia and 25.9% of hemodialysis catheter-related bacteremia. 0.9% of hemodialysis vascular access-related bacteremia was caused by Enterococcus. Vancomycin has been the mainstay treatment for MRSA infection, and it also has a wide spectrum of activity against gram-positive infection. It is a large tricyclic glycopeptide antibiotic having a molecular size of about 1,450 Dalton, and it is mainly excreted and changed in the urine. So its total body clearance is dependent on the function of the kidneys, and there is increased risk of nephrotoxicity if it is given in patients with reduced renal function. In patients with end-stage renal disease, its clearance out of the body totally depends on hemodialysis. The clinical efficacy and safety of vancomycin have been evaluated by pharmacokinetic and pharmacodynamic indices such as time above MIC, AUC by MIC, and Cmax by MIC. The plasma trough concentration of vancomycin has been regarded as the most practical method for therapeutic monitoring of vancomycin, especially in hemodialysis patients, since only blood sampling time before the next dose is required, and the adequate plasma trough concentration of vancomycin before the next dose proves that the plasma concentration of vancomycin is above MIC throughout the time course between the doses. Acceptable therapeutic range of plasma trough concentration of vancomycin is 5 to 20 milligram per liter. So the objective of this study is to determine C-trough-MIC ratio and the microbiological outcome of vancomycin in hemodialysis patients with end-stage renal disease. Let's go on to methods and procedure. This is hospital-based observational study studied in total 19 patients within the study period of 1 year. This is a flowchart of the study procedure. Patients with end-stage renal disease undergoing hemodialysis twice per week who were going to be prescribed intravenous infusion vancomycin by renal physicians due to gram-positive bacteremia were recruited and written informed consent was taken. 3 ml of whole blood sample was collected immediately before the administration of third dose of vancomycin infusion at the steady state during hemodialysis, and vancomycin trough concentration was measured by HPLC UV method, and C-trough by MIC ratio was calculated. Microbiological outcome was evaluated by the blood culture and sensitivity test after completion of the fifth dose of vancomycin according to IDSA guideline. Let's go on to results. The table on the next slide will show the type of dialyzer used, C-trough MIC ratio, and the microbiological outcome of the individual patients. In the second column, it is seen that 12 patients used low flux dialyzer, whereas 7 patients used high flux dialyzers. Accounting CTRA value, while dispersions in value can be seen, ranging from the lowest 4.4 milligram per liter to highest 69.1 milligram per liter. Regarding MIC value, 4 patients had MIC value of 0.5 and the rest of the patients had that of 1, showing that these gram-positive bacteria are sensitive to vancomycin. Regarding CTRAF MIC value, dispersions in value can also be seen as in CTRAF level. Concerning microbiological outcome, 12 patients were regarded as sterile after the completion of 5th dose of vancomycin, whereas 7 patients were positive for gram-negative bacteria, which are not included under the spectrum of activity of vancomycin. In the left figure, categorization of the plasma trough concentration of the patients into subtherapeutic level less than 5 milligram per liter, therapeutic level 5 to 20 milligram per liter, and supratherapeutic level more than 20 milligram per liter. 8 patients had therapeutic level, while 2 patients had subtherapeutic level, and 9 patients had supratherapeutic level. In the right figure, value of CTRAF MIC ratio were categorized into subtherapeutic value less than 5, therapeutic value 5 to 20, and supratherapeutic value more than 20. 5 patients had therapeutic value, and 2 patients had subtherapeutic value, and 12 patients had supratherapeutic value. Although 8 patients had therapeutic level of plasma trough concentration of vancomycin, only 5 patients had therapeutic value of CTRAF MIC ratio. So for discussion, CTRAF of vancomycin of the patients were obviously dispersed in value ranging from 4.4 to 69.1 milligram per liter, although the appropriate therapeutic range of vancomycin is 5 to 20 milligram per liter. Therefore, among 19 patients, 8 patients received acceptable therapeutic range, whereas 2 patients had subtherapeutic value and 9 patients had supratherapeutic value. Effects are considered to explain the wide dispersions of plasma trough concentration of vancomycin. The first one is a dosing regimen. In the study, the same dosing regimen, loading dose 25 milligram per kg, followed by a fixed maintenance dose 500 milligram during each hemodialysis was prescribed in all patients, and this fixed dose maintenance regimen of 500 milligram administered during or after the hemodialysis session can lead the plasma trough level of vancomycin below or above the acceptable range of 5 to 20 milligram per liter. Another fact is the type of dialyzer used. Vancomycin is a large molecule, as mentioned earlier, and high-flux dialyzer can remove it efficiently. Among 9 patients with supratherapeutic level, high-flux dialyzers were used in 5 patients, and low-flux dialyzers were used in 4 patients. The plasma trough concentration level of 4 patients using low-flux dialyzer were acceptable with the type of dialyzer used, but 5 patients using high-flux dialyzers were not acceptable. That's monitoring of plasma trough vancomycin level before next dose is essential in patients either using high or low flux dialyzers. And I also stated that it is important to monitor plasma trough vancomycin level before the 3rd dose in order to decide the dosage of vancomycin to be prescribed, and it is recommended to omit 1 dose of vancomycin if pre-3rd dose plasma trough level is above 20 milligram per liter. On accounting CTRAF MIC ratio, 1 patient having MIC value of only 0.5 had plasma trough vancomycin level of 69.17 milligram per liter, so that this patient's CTRAF MIC ratio became 138.35, revealing that patient's plasma vancomycin concentration is extremely higher than the required amount to defeat the pathogen. This evidence proved that therapeutic monitoring of vancomycin should include not only the plasma level of vancomycin, but also MIC of the individual patient. Evaluating the blood culture and sensitivity, 12 patients were regarded as sterile after completion of the 5th dose of vancomycin, and 7 patients were positive for gram-negative bacteria, which do not include under the spectrum of vancomycin activity. As a conclusion, in this study, only 5 out of 19 patients achieved therapeutic CTRAF MIC ratio value, whereas 2 patients had subtherapeutic value with the possibility of development of resistant strain, and the majority of study group, 12 patients had supratherapeutic value with the vulnerability of the acute nephrotoxicity. Although the dosing regimen of vancomycin and frequency of hemodialysis per week are the same in all patients, CTRAF of the patients are widely dispersed. knowing that the plasma trough concentration of 1 mg dose is essential to achieve the optimal clinical effectiveness of vancomycin. Therefore, the study provides an evidence of the importance of therapeutic drug monitoring of vancomycin in patients with end-stage renal disease and undergoing hemodialysis. This research was funded by Department of Medical Research, Yangon, and ethically approved by Research and Ethics Committee of University of Medicine 1. Thank you so much for your attention.
So thank you very much, Dr. Nushua, for your very comprehensive presentation. Now, floor is open for question and answer, but we have time pressure. We are behind the time. So I think we would like to allow the one question for one speaker, I think. So here
Dr. Mamaji. Yes. Oh, Dr. Mamaji has given a question, and then Dr. William has answered, but maybe Professor Mamaji would like to ask more. So please, Professor Mamaji.
Thank you, Madam Chairperson. I want to ask first question to Dr. Ngu Shewa. First of all, congratulations and thank you all researcher and presenter. So regarding this last presentation, my question is, you studied the level of the vancomycin trough level in CRF patient on dialysis, 19 patients. So regarding your finding, you noticed the subtherapeutic level, and supratherapeutic level. So we clinicians worried about the increasing nephrotoxicity by using antibiotics. So do you want to, because we have noticed I think maybe 12 cases as a supratherapeutic level. So do you want to recommend the lower standard dose of vancomycin in that sort of the chronic renal failure patients? They are going to have their whether maybe dialysis or not. Do you want to suggest the lower dose of the vancomycin regarding because of your study finding?
Yes, thank you so much for your questions, Professor. In my point of view, I would like to recommend to do therapeutic drug monitoring of vancomycin for the next dose to be prescribed, and dosing should be done according to the plasma trough concentration level individually. I think so.
Yes, that maybe I'm being a bit confused. So did you measure the trough level one time or because you get there for 5 days? So 5 days or only 1 day or one time? One time.
Yeah, only one time before the dose.
Is it day 1 or day 2 or day 3 or day 4 or day 5?
It's been day 3.
Day 3.
Day 3. Yeah.
So
is prescribed.
Because after measurement, you want to recommend the reducing dose because the trough level is very high. Is it okay? Like that. So the only recommendation you want to recommend you need the measurement, but recommendation depend on the results. Is all right?
Yes, right. The dosage modification will be done after the trough level measured. Yes.
Okay. Thank you.
Thank you so much.
So any other questions? So no more question, or I'd like to conclude because we have no time left. Okay, so thank you very much as speakers about your very much informative research findings. And thank you very much for our audience to participate this section and your discussion. And now, so we would like to we would like to also thank to our Myanmar Medical Association Organization Committee to organize this this conference. And then we would like to thank to admin and technical members to get the smooth conduction of this virtual paper section. So thank you very much all.
Congratulations all speakers.
Bye. Bye.
Thank you. Bye-bye.
Bye. Thank you.
This session will leave, no? ဒီ session တစ်ခု
Okay,
ပဲ
Mama.
Okay.
Okay, Mama. This section တစ်ခုပဲ leave တင်တယ်
session တစ်ခုပဲလေ Okay.
ကျေးဇူးပါ Mama.
ကဲပါ
ကျွန်တော်အချိန်ကအရင်နေတော့လို့ Okay.
ကဲပါ
Mama နဲ့လည်းကျေးဇူးပါလို့အားလုံးဟိုကျေးဇူးပါဟိုပါလေ speaker တွေအားလုံးအရန်ကိုတော်ပါတယ်ကျမဟိုပါလေညီမတို့ဟာနဲ့ပတ်သက်ပြီး
အရန်တော်
Okay. ချိန်မရှိလို့ Okay ကျေးဇူးပါအဲ့ဒါဆိုရင်ဟိုကကျမတို့ဟိုကလောက်ကြပါ admin ကဘာလုပ်ပေးမလဲမသိဘူးဟိုဘာကိုပဲထွက်လိုက်ရမှာ Thank you bye
bye bye